In this video, I'll talk to you about various techniques for linear regression. First of all, what is linear regression? Well, it's a way to find a linear equation that closely models a given set of data points. And as we'll see, we can find a good fit for the data points by hand, just using the regular techniques that we've already learned. But finding the best fit is going to require some technology. So first I'm going to show you how to do it by hand, just using a calculator if that's what you have. And then I'm going to show you a couple different ways that we can use computer technology to do this. So we'll work through this with an example. So in this case, we've got a collection of data points that show us the time that it takes to fly from Chicago to these various cities, and then the price of a nonstop one-way plane ticket to get from Chicago to those cities. So the first thing that we need to do if we want to find a linear model for these data points is that we need to graph the data points. So we're given a grid here, and so the first thing that we're going to have to do is figure out how to label the axes on this grid so that we can plot our data points. The first thing to realize is that whenever you're given a table of values like this, the first column that you get is going to be the x values that you use, and the second column that you get is going to be the y values that you use. If the table is given with two rows of data, the first row will be the x values, the second row will be the y values. So when we label here, we know that time is going to go along the x-axis, and again that's in minutes, and then price is going to go along the y-axis, and we're given that in dollars. So now we have to figure out what each of these boxes represents. And this is going to vary from problem to problem, but let's start with the time. So what you want to try to do is find the lowest value of time in your table, which here is going to be 65 minutes. And then let's also find the highest time in the table, and that's going to be right here next to it, 265. So that means that however we label our axis here, it has to include the numbers between 65 and 265. Now, to make your life easier, what you usually want to do is try to pick some nice round numbers so that you're not having each box represent, 57 minutes or something like that. You don't want to pick a weird number. You want to pick nice numbers like increments of 10 or increments of 20 or 50, something like that, so that you have enough room to fit all your data points and you're using nice round numbers. In this case, since 65 is fairly close to 0 in this scale that we're using here, let's just have our first box here represent 0 minutes. Now, we have 10 boxes. If we count how many boxes we have here, we have 10 boxes on each axis. So if we have the boxes go up by, let's say, 20, that's only going to be 10 boxes times 20 minutes per box. That's 200. That's not enough. So if we go up by 30 in each box, that is going to be enough. That's going to get us up to 300. So let's do that. So this will be 30, and then 60, 90, and so on. 120, and we keep labeling until we get up to the end. And again, depending on how many boxes you have and the size of the boxes, this is going to be different for each example. But this is going to work for us from 0 to 300. Now we're going to do the same thing for the price axis. Again, find the lowest and the highest values. In this case, the lowest price is 89, and the highest price is 199. So we could go anywhere from between two numbers that includes 89 to 199. Again, let's go ahead and start at 0. Not always going to start at 0, but in this case, that's pretty close to working for us. And then let's go all the way up to 200. Since the highest number is 199, we can stop at 200. And that means that since, again, we have 10 boxes, that means we're going up by 20s. So 20, 40, 60, 80, 100, 120, 140, 160, and 180. Now that we have our axes labeled, we're just going to plot each of these points. So the first point is going to be 110, 140. So we find 110 on our x-axis. Now 110 is between 90 and 120, a little closer to 120 than 90, so that's our x value. And then 140 is going to give us this point right here. So that point represents Atlanta. And then we keep going. So 260, 199. 260 is between 240 and 270, a little closer to 270. And then 199 is almost all the way at the top of our y-axis. 80, 108. 80 is between 60 and 90, a little closer to 90. 108 is between 100 and 120, a little closer to 100. So that's going to be right around there. This doesn't have to be exact, but you want to make sure that your points are if they're in between the lines, you want to make sure that they're in between the correct pair of lines. And also, if they're closer to one line than the other, make sure that you're drawing it that way as well. Next up is Oklahoma City. 125 for my x-coordinate, that's going to be very close to 120. And then 130 for my y-coordinate, that's going to be exactly halfway in between 120 and 140. So that's going to be right around there. 85, 89. So a little bit closer to 90 than our previous value, and then 89 is going to be pretty much exactly, not exactly, but pretty close to halfway between 80 and 100. So that's going to be right around there. 170, 175. 170 on my x-axis is between 150 and 180. 175 on my y-axis is going to be pretty close to 180, between 160 and 180. Next up is 225, 191. 225 is exactly halfway in between 210 and 240, and 191 is going to be a little bit above halfway between 180 and 200. So that point's going to be right around here. Next up is 155, 147. 155 is just above 150. 147 is a little bit less than halfway between 140 and 160, so that point is going to be right around there. Almost done. 265, 196. 265 is very close to 270. 196 is again going to be almost all the way at the top, so it's going to be right around there. And then finally 65, 93. 65 is very close to 60, and then 93 is a little bit above halfway between 80 and 100. So there are our data points. And now that we've got these points plotted, what we can visualize is that there's a linear relationship between those points. We can imagine drawing a straight line that would go pretty close to all of these points. And so what we're looking for is the equation of that line. So now how do we go about actually finding an equation of a line that fits these points? Well, what we're going to do is we're going to pick two of the points. And there's a lot of different good choices that we can make. But basically what we're looking for is 2 points where when we draw a line that connects those 2 points, that line goes as close as we can make it to going through all of the data points that we have. So for example, one good choice that we could make is this point right here and this point right here. So that if we connected those 2 points with a line, that line would look something like this. And as we can see, that line comes pretty close to going through all of the points that we've plotted. There's lots of different choices that we could have made, but let's go with these 2 points. If you decided to choose a different pair of points, then your equation of your line that you're going to get is going to be slightly different than the equation that I'm going to get. All right, so which points did we pick? Well, this point here, again, looking back at the choices that we had, the y value was between 100 and 120, and when we see at our list, it looks like that point was the Nashville point. So that point that we picked was 80, 108. And the point up here, again, looking at our choices that we had, that x value was between 210 and 240, so that must have been the point Phoenix, Arizona, 225, 191. So this is the basic idea for finding a model by hand. As we already did number 1, we chose 2 data points so that a line connecting those 2 points comes as close as possible to all of the data points. And now we're just going to find an equation of the line that connects those 2 points in the way that we normally would. So just to remind you, the 2 points we chose were 80, 108, and 225, 191. So remember how we do this. First we find the slope. The slope is the change in y over the change in x, the rise over the run. Remember that's y2 minus y1 divided by x2 minus x1. In this case, my y2 is 191, my y1 is 108, my x2 is 225, and my x1 is 80. 191 minus 108, that's 83, and 225 minus 180, that's 145. Now, in other situations, we might leave this as a fraction. In this case, since we're modeling our data, we know that this is not going to be exactly a line that fits every single point, and so it makes sense to just go ahead and use an approximation. So putting that in my calculator, I get that this is approximately equal to 0.5724. And again, in different situations, we might use more or fewer decimal places. In this case, I usually sort of default to 4 decimal places just because that's usually enough to get pretty reasonable accuracy. But in any given problem, if you're being told to use a certain number of decimal places, go ahead and follow those instructions. All right, we found our slope. Now we'll use our point slope form. Y minus y0 equals m x minus x0. We can use either one of these points. I'll just go ahead and use the first point. So this is y minus 108 equals m, which is 0.5724 times x minus x0, so that's 80. 0.5724x. When I multiply 83 over 145 by 80 and put that in my calculator, I get 45.7931. Add 108 to both sides, I get 0.5724x plus 62.2069. So that is my model for my line. And again, if you chose two different points, your model is going to be slightly different, but it should be pretty close to this. The slope should be around positive 0.5, 0.6, somewhere in that neighborhood, and the y-intercept should be somewhere around 60, somewhere in that neighborhood. If you're getting wildly different numbers, then take a look at the line that you drew, and you might find that that line doesn't really go that close to some of those data points. So you really want to follow the instructions for number one here. The first thing you want to do is don't just pick two random points. Pick 2 points so that when you draw the line connecting those 2 points, it really does come as close as you can make it to all of the data points. All right, now that we have our linear model, and again, I'll remind you of what our equation was. It was y equals 0.5724x plus 62.2069. Now we can answer questions like this. We can make predictions, we can make interpolations of other kinds of data points that would fit this model. So for number one, we're asked to estimate the price of a flight that has a nonstop flight time of 4 hours, and they conveniently tell us that 4 hours is 240 minutes. Remember that x was the time. We decided that right at the beginning because that was the first column in our set of data points, and y was the price. So if they're telling us that the time is 240 minutes, now that tells us that we can use our equation just by plugging in 240 for x. So we get y equals 0.5724 times 240, plus 62.2069, and then we throw that in our calculators, and we get 199.5829. Now, y is price. Usually we express price in terms of dollars and cents, so it makes sense to round this to 2 decimal places, so 199.58, $199.58. Now, is that exactly what the price is going to be? No. We're using a model. We found a model that comes close to the data points. But what this tells us is that we can ballpark and expect that the price of this flight should be somewhere in the neighborhood of $199. And now for question two, same idea. Now we're being told that a particular flight costs $150, and we want to estimate the time. So that means that y is equal to 150, and we need to solve for x. 0.5724x plus 62.2069. So subtract 62.2069 from both sides. That gives us 87.7931 equals 0.5724x. Divide both sides by 0.5724, and that gives us 153.377. Now they don't tell us how to round this, but let's just round it to the nearest whole number. So this is approximately equal to 153 minutes. Again, we can't expect that that answer is exactly correct, but it should be pretty close to whatever the exact answer would be, because again, we're modeling data points that don't exactly fit along a single line. All right, now let's move on to this idea of finding the line of best fit. So what we're going to see is using a method called least squares regression, and you don't need to worry too much about what that actually means. Feel free to Google that if you're interested in learning a little bit more about what that actually means. But it's just a method for finding what we call the best fit. And that's not something that we can really do by hand. So we're going to use Microsoft Excel, and I'm also going to show you how to use Google Sheets to find this least squares regression with the best linear model for a set of data points.
Okay, so first I'm going to show you how to do this with Microsoft Excel. I've opened a blank workbook here, and now what I need to do is type in the data points that were given. So I've got 3 columns, the name of the city, the time in minutes, and the price of the flight in dollars. And now I just start entering the data one at a time. So my first city is Atlanta, the time was 110 minutes, and the price was 140, and so on. Los Angeles, 260, and 199. So we keep doing this. Now the city names are not exactly required here, but it's good to just have a reference for the data set that you're given. I'm going to use a shortcut because I've already entered the data here, and once you get everything entered in, here's what you do. You highlight the data points, and then you want to go here to Insert, and then here's where you're looking for the charts. And the type of chart that we want is a scatter plot. So we click that. We just want a bunch of dots. Now, if you notice, it's going to give us a preview that isn't really quite what we want, but let's go ahead and click that button anyway. So the chart that we get here has each of the 2 columns listed as y values, whereas what we want is to have the first column be x values and the second column be y values. So we can do this really easily. Go here to where it says Change Chart Type, And then we see there's actually two options, one which is the preview that it gave us, and then the other option is what we want, which is the x and y values. So we hover over that second option, click OK, and that gives us our scatter plot. And we can see if we compare this to the scatter plot that we had before, this looks pretty close to what we had. So now what we want is to have that line, the regression line that fits these data points. So what you want to do is click the plus sign to add a chart element. And what we want is, Excel calls it a trend line. So we click that, check that box, and now what we can see is that we've got this trend line drawn on our screen. But we don't have the equation for the line, which is the whole point here, is to get that equation. So click this little arrow, and what we want is more options. And it pops up a little sidebar, and on those options, the option that we want is where it says display equation on chart. Now it comes up pretty small, it might be a little hard for you to see on this video, so I'm going to make the text a little bit bigger for you to see. But we've got our equation, y equals 0.5426x plus 63.234. Now that's not exactly the equation that we got when we did it by hand, but it's still pretty close. Remember I said that we should get a slope that's between about 0.5 and 0.6 and a y-intercept that's somewhere around 60, and that's what we're getting here. But this is in a way the quote-unquote best regression line because it's using this least squares idea. So it's really kind of fitting the data as well as it possibly can. So that's how we do it in Excel. Type in the data points, insert a chart, you want a scatter plot, and then you have to change the chart type to get the X and Y plot. Then click the plus sign, trend line, click the little arrow, more options, display equation on chart. And that's how you get it. Now, if you don't have access to Microsoft Excel or you'd like to use a different option, something else that you can use is Google Sheets. So you're going to point a web browser to sheets.google.com and open up a new spreadsheet. And you'll get a window very similar to what you'd get when you open a blank spreadsheet in Microsoft Excel. So again, we want to start the same way. We're going to type in our data. So the city name, the time in minutes, and the price in dollars. And again, one at a time, start entering your data, Atlanta, Georgia, 110, 140, and so on. And again, I'm going to take a shortcut and paste in my data from another window. And now again, what I want to do is highlight this data. And here what I want to do is go to insert. So insert, and what I want is a chart. So I click that, and then Google is going to sort of guess what I want, but this is not obviously what I want. I don't want a bar chart. What I really want is a scatter plot. So over here on the right is where I see chart type, change column chart to, now here's the scatter plot that I want, you see with the dots. Again, we can see that this looks very similar to the scatter plot that we did by hand and the scatter plot that we got from Microsoft Excel, but it doesn't have the line that we want. So what we want to do is click Customize on the chart editor. And the option we want to use is Series. So click Series, and then down there, again, we see the word trend line. That's what we want. So click that little checkbox. You can see that it draws the trend line for us. And if we scroll down, Label is the option that we want, and we want the label to use the equation. And so now we can see in our legend over here that this blue box that's representing the blue line, the light blue line here, is giving us the equation 0.543x plus 63.234. And that's very similar to the equation that we got from Excel. The only difference is the number of decimal places. So Google is giving us a different number of decimal places here. But otherwise, it should be the exact same equation, regardless of which tool we use. So I hope this gives you a good overview of the different methods that you have for finding the regression line for a given set of data points. We can do it by hand. That usually gives us a pretty good answer, assuming we pick a good pair of points. But if we want a more accurate answer, we can use a technology tool like Excel or Google Sheets.